हेलो स्टूडेंट्स, हाउ आर यू। होपफुली आप सब बहुत अच्छे होंगे और बेटा अपनी पढ़ाई कर रहे होंगे। डेयर स्टूडेंट्स, in the atomic structure we discussed rules for writing electronic configurations in terms of SPDF subshells. Now at last there is the Paulie's exclusion principle. Before this law we already discussed above principle as well as Hund's rule of maximum multiplicity. Now what is Pauli's exclusion principle of filling of electrons in the orbitals as well as what is its importance? Let's देखिए बेटा, अकॉर्डिंग टू Pauli's exclusion principle, filling of electrons in any orbital generally takes place maximum number of electrons 2 with the opposite spin. That is when we have to fill 2 electrons in an orbital, then we have to always fill with the opposite spin. As you know, maximum number of 2 electrons can be filled in an orbital. Basically, what do you mean by this one? We can say, according to this principle, no 2 or more electrons in an atom can have all 4 quantum number values same, or each electron has unique set of quantum numbers. It means this one. इनके अकॉर्डिंग किसी भी एटम में कभी भी 2 इलेक्ट्रॉन के चारों क्वांटम नंबर सेम नहीं हो सकते। मैक्सिमम हो सकता है बेटा प्रिंसिपल क्वांटम नंबर सेम हो, बिलोंग्स टू द सेम ऑर्बिट इलेक्ट्रॉन। हो सकता है सेम सबशेल तो बिलोंग करें, एजिमुथल क्वांटम नंबर सेम हो, मे बी हैव सेम ओरिएंटेशन और मैग्नेटिक क्वांटम नंबर. But at least if all these 3 are same, then at least spin quantum numbers must be different. That means in any atom, no 2 electrons can have all 4 quantum number values same. It is always each and every electron within an atom has its specific, unique set of all 4 quantum numbers. This is Pauli's exclusion principle. That means each and every electron in an atom has a specific exclusive set of quantum numbers. If we find out, as you know, quantum numbers are those numbers which provide you complete information about an electron within the atom. Okay, suppose we talk about 3D z square. This is the orbital. Find out all 4 quantum number values for this one. So बेटा जो ये आगे लिखा होता है, this is the principal quantum number, and for D it is already discussed. Value of azimuthal quantum number is 2. Magnetic quantum number इसके लिए बेटा 0 होती है, we already discussed. And spin quantum number, because here are 2 electrons, so for the 1 electron spin quantum number is plus half. So another electron spin quantum number is minus half. So if we talk about this electron, so it is plus half, and the set of quantum numbers for other electron present in the same orbital is written as. So these 2 electrons can't have all 4 values of quantum number same. Maybe 3 values of quantum number will be same, but not all 4. बाकी बेटा ये कुछ चीजें आपको याद रखनी होंगी when you find out quantum numbers. Remember, for the given value of principal quantum number, values of azimuthal quantum number varies from 0 to n minus 1. For S, L0. For P, L1. For D, L2. For F, L is 3. It is already assigned. Magnetic quantum number values overall is 2L plus 1, but these values varies from minus L to plus L. How can you find out magnetic quantum number values? Orientations, orbitals for each subshell, these are the different. Okay, For S subshell, magnetic quantum number represented by 0. For P subshell, magnetic quantum number represented -1, 0, +1. For D subshell, magnetic quantum number represent -2, -1, 0, +1 and +2. ठीक है, it is for S. It is for generally Px. This is for Py. This is for Pz. This is for Dxy. This is for Dyz. This is for dz square, and this is for dxz, and this is for dx square y square. These are the values corresponding to the different orbitals. So values of m, values of L, and for spin quantum number there are two values, plus half and minus half. Generally we take plus half for the upper arrow and minus half for lower arrow. We can find out spin quantum numbers. ओके, सो दिस इज पाउलीज एक्सक्लूजन प्रिंसिपल. इसकी इंपॉर्टेंस ये है कि आपको किसी भी एटम में कभी भी 2 इलेक्ट्रॉन या इससे ज्यादा इलेक्ट्रॉन कभी नहीं मिलेंगे जिनमें चारों क्वांटम नंबर वैल्यू सेम हो. ईच एंड एवरी इलेक्ट्रॉन हैज इट्स स्पेसिफिक यूनिक सेट ऑफ क्वांटम नंबर्स exclusively. Now, how can you find out magnetic properties? बेटा अगर हमने पता करना हो कि एलिमेंट की मैग्नेटिक प्रॉपर्टीज में कि कोई एलिमेंट पैरामैग्नेटिक है या डायामैग्नेटिक है, तो हम कैसे फाइंड आउट करेंगे? पैरामैग्नेटिक के लिए you should know element should have at least one unpaired electron in its electronic configuration. When we write electronic configuration of element, and if there is at least one electron as unpaired or singly filled or monotonically filled, then we can say the species or element is said to be paramagnetic. And if all electrons are paired in the electronic configuration, it is said to be diamagnetic. Their paramagnetic moment can be found out by formula n of n plus 2 Bohr magneton. Remember, paramagnetic substances also have tendency to attract slightly in the external magnetic field, and diamagnetic substances are those which are slightly repelled when these are placed in the external magnetic field. This is the magnetic moment or paramagnetism, which can be determined by this formula, where n is the number of unpaired electrons. Whenever it is asked to find out this one, we can find out. Definitely value of this for diamagnetic is 0. It is 0 for diamagnetic substances. For diamagnetic substances, its value is 0. Okay. For example, suppose मैंने कहा find paramagnetic moment for Mn2+ and for zinc 2+. So first of all, write down the electronic configuration of Mn. It is argon 18 and then 3d5 4s2. It is for Mn. Now for what is Mn2+, we have to remove 2 electrons. Electrons are always removed from the outermost orbit, that is from the 4th orbit, not 3rd. So we have to remove 2 electrons. 2+ means we have to remove 2 electrons. You know, this is the 4s and this is the 3,5. Basically this is the orbital inside, this is the penultimate shell, but electron we have to remove from the outermost orbit. Remember this thing. Okay, that's why I written it 4s2 later before 3d5. Now Mn2+ configuration, it is argon 18 and it is 3d5 and it is 4s0. So if we distribute electrons in 3d5, 1 2 3 4, these are the 5 unpaired electrons according to the Hund's rule. We have to fill 1 1 1, and in 4s0 there are no unpaired electrons. So these are the 5 unpaired electrons, so n value is 5. Now we have to find out magnetic moment n of n plus 2 Bohr magneton. This is the unit. Put the value of n here, 5 5 plus 2, and it is 35 and it is nearly 5.9 Bohr magnetron for the Mn2 plus. Okay. Similarly for zinc 2, it is paramagnetic. When it is placed in the external magnetic field, it should be slightly attracted. Unpaired electrons are 5. These are the number of unpaired electrons. Filling should be according to the Hund's rule. 1, 1, 1. Then if number are greater, then paired with the opposite spin. In case of zinc, you know, zinc का atomic number beta 30 है. It give you argon 18. This is the argon. And here is the 4s2 and 3d10. This is the filling according to above principle. Now after filling, you can write 4s2 as the outermost. Now when we talk about zinc 2 plus, remaining is same, it becomes 4s0 and 3d10 is completely filled up. So there is no unpaired electron. For this case, unpaired electron is 0. So its magnetic moment is also 0. So we can say zinc or Zn2 plus is diamagnetic and it is slightly repelled when placed in the external magnetic field. Or if we talk about manganese, chromium, iron, okay, like such elements will show some paramagnetism even in their ionic state. So for when we write ionic state electronic configuration, if they are positive charge, then remove electron from the outermost, and if a negative charge, then fill the electrons according to above principle, that is the increasing order of energies. Okay, so this is the Paulies exclusion principle and calculation of paramagnetic or magnetic moment and Paulies exclusion principle. Dear students, now you have to do practice more and more to write electronic configuration as well as to find out their paramagnetism, as well as to find out which one is paramagnetic or diamagnetic. Okay, and if you have any problem, then you can call me or message me. Okay, thank you. Thanks a lot.